Okay, welcome once again from wherever you're joining us again. Good afternoon, good morning, good evening from wherever you're joining us. It's good to have you once again on our platform, and we are also having continuing on our tutorials as well. For wherever you're joining us, thank you, thank you. Please, for those that have subscribed, I say thank you so much. And if you're yet to subscribe, what are you waiting for? Just go ahead, click the subscribe button, click the like button, click the notification button so that you get updates as much as we drop content. And please share also the content to as many as possible so that they can benefit from this tutorial session. And it's educative, it's interesting, and it's a journey, it's a progress for to our advantage as we learn. So thank you once again. Thank you once again for those that have shared, like, comment. I say a big thank you for our subscribers. I say thank you, thank you, thank you. Thank you once again. So today we'll continue in our tutorial section as well. And, we started with application of Newton's law of motion. Yes, the application of Newton's law of motion. So today we'll also be continuing uh, in the topic in the course. So last time we look at some calculations. Today we also be considering some calculations as well, and also the application, the practical, the practical applications to these principles and laws. So today we have another question here, still under the application. A car of mass 200 kilogram moving with a speed of 30 meters per second was suddenly hit by another car moving in the same direction. What is the impulse received by the first car if the speed attained at the time of impact is twice its initial speed? So we have a question here that says a car of mass 200 kilogram. Now, what you do is begin to highlight for those writing WAEC, and since you'll be writing a theory-based question, where you have to provide your workings and your steps and whatever. So one of the things that gives you a good stand points and answers to your questions is that when you want to answer your question, please try and highlight. This is particularly for calculation-based subjects, either mathematics, physics, chemistry, or any subject that relates to calculation. So try and itemize your parameters, that is all the values given to you in the question. It helps you to know which and which you are looking for. So the question here says a car of mass 200 kilogram. So we have our mass to be 200 kilogram, is moving with a speed of 30 meters per second. With a speed. Now, there's something I want to bring out here. When you in physics generally, anywhere you see the word with a that has to do with speed, with a anywhere you see this word, most times it relates to initial velocity, which is u. Most time is related to initial velocity, which is u. That's initial velocity. Initial velocity, which is u. Yes. So whenever you see a question that goes with a car moving with a speed most times about 90 to 95%, it relates to what? Letter U, which symbolizes the initial velocity. So please take note of that. And it's very, if either you're writing WAEC or you're writing JAM, please take note of this. So in physics, most especially, whenever you see a question under any subject or any topic in physics that engages speed, velocity, distance, and all the principles of motions applied, and you see the word with a, tells you what? Your u, which is your initial velocity. So back to our question, we have a car of mass 200 kilogram moving with a speed of 30 meters per second was suddenly hit by another car moving in the same direction, was suddenly hit by another car moving in the same direction. What is the impulse received by the first car if the speed attained at the time of impact is twice its initial speed? Now let's look at the concept now. We have, this is a car. Let's assume this is a car. Now this is another car. So we have car A and car B. So car A is moving with an initial velocity of 20 meter per seconds. So this is moving with an initial velocity. So let's say our U here is what? 30 meter per seconds. Now the mass of this car is 200 kilogram. Now a car of mass 200 kilogram moving with a speed of 30 meter per seconds was suddenly hit. Now this second car, car B, comes to hit this car, was suddenly hit by another car moving in the same direction. Now there is a collision here. This car hit this other car and they move in the same direction. Now look at it. They move in the same direction. So when the collision takes place, both of them goes in the same direction. Now what does it mean? They move together. Both of them move together. So this goes into this. Now, so here is just a pictorial representation. This car B, it's car A. There was a collision and both of them moves in the same direction. So that is what the question is trying to tell us. So both of them move in the same direction. Remember, this first car, which we're given is 200 kilogram at initial speed of 30 meter per second. Another car coming to hit the car suddenly, the car A suddenly, and both of them moves in the same direction. Both of them moves in the same direction. Now the question says, what is the impulse received by the first car? This is first car. This is the first car. This is the second car. So the question says, what is the impulse received by the first car due to the effect of this second car hitting the first car? So, and that's what the question says. So we want to look at the impulse, that is, what is the magnitude of the impact that this car received as a result of this hitting this car. Now, another thing you need to take note that this car B, this second car, hit the first car, and both of them moves in the same direction. So there is another principle to this, which we'll discuss subsequently when we get to principle of elastic collision and inelastic collision. That's principle of momentum. Yes. So when we go further into the topic under the principle of momentum, so we'll now look at elastic collision and inelastic collision. So, but for the sake of this question now, just to quickly address this problem, so we are looking for the impulse. And remember in our last class, please, for those that missed the previous episode, please just go to other episodes that we have, other content that we dropped. you will check where we explain about all the formulas, some of the formulas under this Newton's law of motion. And the one of the formulas we talked about impulse, one of the formulas we talked about impulse. So having understood this concept now, we are to find the impulse, yes, of this car because of the effect, due to the effect of this hitting this car. So we go back to our formula again. Impulse is equal to change in momentum. If you can remember, change in momentum. I is equal to, so our I impulse is equal to what? Mv minus mu. If you can remember, change in momentum. So when there's change in momentum, it means the change in velocity as long as the mass is constant. So we have I is equal to m into bracket v minus u. So that is the formula. This is the impulse. We have the m is equal to v minus u. This is change in momentum. Now back to our question. It says, what is the impulse received by the first car if the speed attained at the time of impact is twice its initial speed? Now, they say we should look for the part if the speed attained after the impact. Remember, this is our initial velocity or initial speed. Now, the question says, what is the impulse received by the first car if the speed attained after the time of impact is twice? So definitely our V will be 2U. Our V will be 2U because the question says the impact here created twice the speed. So, and this V is equal to what? 2 times 30 meter per second, and that gives us what? 60 meter per seconds. That's for V. So now back to our question now to find the impulse. So our impulse is what? Our M is what? 200 kilogram. Our V that we've gotten here is 60, which is twice. And our U is what? 30. So we have 200. 60 minus 30 is what? 30. And that will give us 200 times 30 will give us what? 6,000. 2 times 3 is 6. You add the remaining 3 zero to it. To give us 6,000 Newton seconds. That's the unit for impulse. How do we get it? Remember, impulse is what? Ft is equal to your impulse, also known as, is also equivalent to Ft, that is force times time, and it's the same to as mv minus mu. So force times time is Newton seconds. Newton seconds. So that's where we got this unit from. So now to the next, another question or to another application. So we want to move to another application of Newton's law of motion. So okay, so now we want to consider another application of Newton's law of motion. We want to consider another application of Newton's law of motion, and this has to do with weight of a body in a lift. Weight of a body in a lift. And of course, for those that are familiar with all these tall buildings, they make use of lifts to, transport people up and down the building. So maybe you have a building that is 5-story building, 7-story building, or 10-story building. So, and to avoid the stairs. Instead of taking the stairs, the lift elevator system is there. So it takes people from the ground floor to whichever floor you are going to. So, and one of the application of this law has to do with the weight of a body in the lift. That is, how do your body respond to the mechanical system of the lift? Is it that you have more weight or your weight decreases? I know one thing that scared me when I was much younger, much younger, was you know going high. I had a little phobia for it. Going to the top of the mountain, I was always scared because I was thinking I would fall. So I was always scared. So if I didn't have someone that is older than me to follow me, I would never dare it. And especially when now comes to now staying inside the lift, that the lift will not be carrying you up. And especially if you are privileged to see outside, maybe the lift is transparent, and you're privileged to see outside, and now climbing up, you're not looking at the lift as it's going up, and you're looking down. Oh, see everything, it can be very frightening. So when I was much younger, so I was scared. But as much as I grew older, I was not scared of lifts again. So in this concept now, I want to understand the application of Newton's law of motion. And look, of course, we have three different laws of motion. We have the Newton's first law of motion, which is the law of inertia. Uh, in our previous episode, in our previous tutorials, we've talked about that. The law of inertia, the law of conservative momentum, and the third one, the law of reactional forces. Yes, reactional forces. So the first law states that an object will continue in its present state of rest or in constant motion except an external force acts on it. That's the first law of motion. Now, the second law of motion states that, talks about the principle of conservative of momentum. That is, a momentum will continue as long as every factors is in place. So anything that makes a momentum to change, the rate of the change is equals to the force that caused that change. So just like the previous example that we looked at, the previous calculation we looked at about a car and another car colliding. So a car that was going on its own, another car hitting it back. So what makes the first car to change direction is as a result of the effect or the impact of the second car that hit it. So the second law of motion tells us that the rate of change of momentum, that is the car changing speed or changing direction, is proportional to the force of the car that hit it. So that is just, then the third law says for every action, there's an equal and opposite reaction. Yes, that is under reactional forces. We'll also go into that, consider that. But for this um, one we have here now, we have weight of a body in a lift. It's one of the application of Newton's law of motion. So, and we have about 4 or 5 concepts to this. Number one, when you're inside the lift, when the lift is ascending, of course, lift, or we have the British and the American English. I think the British calls it elevator. The American calls it lift. If I'm right, well, I'm not a grammarian, so our grammarian people will help us with that. But you can also check to be sure, because these are some of the things that there are some of the tips you need to know, especially for those writing jump and like for your English language, to be able to differentiate British English from American English. But for the sake of this class and for the sake of this our subject we are considering for understanding sake, so we'll be using lift here. So now we have the weight of a body in a lift. So the lift, like I said, is just allows people to move up or down a building, where we have building that has more than one story building, has two, three, four, five, six, as numerous story building as that. So the lift is just transported from one floor to the other, first floor, second floor, third floor. So, but what now happens when you're inside the lift and the lift begins to ascend? The lift begins to ascend, the lift begins to ascend, to ascend. Probably you are on the ground floor and you are going to the fifth floor. So, how do you move? How do you move? How do you move? Now, when lift is at rest, that is when the lift is not working, it's at rest, it's not transporting anybody, your weight is equal to mass times acceleration due to gravity. Our G is acceleration due to gravity. And of course, that is true. Gravity has its effect. When we get to gravitational force under physics, under mechanics, and when we get to gravitational force, we'll talk more about gravitational force, gravitational pull. That is, the gravitational pull or gravitational law state that the earth has a force that pulls everything to its center. And that's one thing that you must always remember, that there's a popular saying which is verified scientifically, that anything that goes up must surely do what? Come down. So if I throw this marker now, if I should throw it up, definitely it must surely come down due to the law of gravity. So if I should throw it up, definitely must surely come down because of the effect of gravity. You can't see gravity, it's an abstract, but its principle is in place, its force, its effect, its impact is in place. So if you jump up, you must surely do what? Come down. So of course, I know there's when we get to aerodynamics, there's another aspect in physics where we talk of aerodynamics and mechanism of, when we talk of flying, and so where now begin to ask, oh, aeroplane flies. So why does gravity not act on aeroplane? That's another class. We'll consider that. So, but for the sake of, let's limit ourselves to this for the sake of this class. So when weight is at rest, your weight is equal to your mass, that is the weight of your own body. Maybe you are 20 kg, you are 50 kilogram, you are 70 kilogram, you are 100 kilogram. So the weight of your body inside the lift, when the lift is not working, you stood inside the lift, you are standing there, and the lift is not working. It might be powered on, but it's not working. So your weight